Welcome to this video. In today's video, I'm going to do a very interesting problem of Czech and Slovakia Republic's Olympiad, but it doesn't say which year this problem, okay? So for each natural number n superior or equal to 2, we have the sequence Vn equal to sine x sub 1 multiplied by cosine x sub 2 plus sine x sub 2 multiplied by cosine x sub 3 and so on all the way down until you get the last term sine x sub n multiplied by cosine x sub 1. We have the x1, we have the x sub 1 through the x sub n are arbitrary real numbers. The question: determine the largest possible value of the expression. Okay, the goal of this problem, we are going to maximize this one to find the largest, the maximum, the value of the Vn. That's the goal. So go ahead, pause this video if you would like to give a try to this problem. When you're ready, come back to see the full solution. Okay, let's get into the solution now. We take a look at the last term. We see the cosine x sub 1. That's mean cosine of x sub n is growing up this way. Both sine x and cosine x are growing in opposite direction. Okay, as you see here, that's what happened in this problem. This is the trick of this problem. So the term before the last term, I should have sine x sub n minus 1 multiplied by cosine x sub 2. The term before this one, I should have the sine of x sub n minus 2 multiplied by cosine x sub 3. Okay, and all the way down. As we know a minus b quantity squared equal to a squared minus 2ab plus b squared superior or equal to 0. Okay, this one is equivalent to a squared plus b squared superior or equal to 2ab. Okay, so we have ab is inferior or equal to a squared plus b squared over 2. Okay, this is the formula that I'm going to apply in this problem. Okay, the last term is involved with sine xn multiplied by cosine x sub 1. That means cosine x sub 1 is going up this way. Okay, so I'm going to apply this identity here. So as you see here, the first term, we have the sine x sub 1 multiplied by cosine x sub 2 is inferior or equal to this one, which is sine x sub 1 squared plus cosine squared x sub 2 over 2. The second term, I will have sine x sub 2 multiplied by cosine x sub 3 is inferior or equal to sine square x sub 2 plus cosine square x sub 3 over 2. Okay, and all the way down until you get two last terms. We have sine cosine square x sub 1 over 2. Okay, if I'm going to match these numbers together, I will have this one, I will have this going to do the sum of this one. Okay, to see what's given us. Capital A. Okay, as you see here, you have Vn is inferior or equal to capital A. Capital A, I'm going to bring this one at the top, as you see it here. So I will have the sum of sine square x sub 1 what I did here, I just brought this one at the top. Vn is inferior or equal to capital A, which is, I'm doing the sum of this one, sine square x sub 1 plus cosine square x sub 2 over 2, and all the way down until you get the last term, which is sine square of x sub n minus 1 plus cosine square x sub 1 over 2. Okay, I'm going to match these numbers. I'm going to combine this number together. As you see here, sine square x sub 1, there is a cosine square x sub 1 at the end. Okay, so I'm going to bring this cosine square x sub 1 to the sine x. As you see here, we have the sine square x sub 1 as a first term. We have the cosine square x sub 1 as a last term. Okay, I'm going to bring this cosine square x sub 1 to the first term, which is sine square x sub 1. Okay, also if you take a look at before the last term, cosine x sub 2, we have the sine square x sub 2 as well as a second term. So that the term before the last term is a cosine square x sub 2. The second term is a sine square x sub 2. The sine, as we said before, the sine is growing this way, okay? And cosine is growing in the opposite way, okay? That's why we have this combination. So now, what does mean this one? So the sine square x sub 1 plus cosine square x sub 1 over 2 plus the sine of square x sub 2 plus cosine square x sub 2 over 2, and all the way down until you get the last term, which is sine square x sub n plus cosine square x sub n over 2. Okay, as you see here. So now I have this one, I have all the way down all these numbers. Okay, so we have Vn is inferior or equal. So as you know, sine square x sub 1 plus cosine square x sub 1 is equal to 1. Okay, so 1 over 2. Same thing with the last term, 1 over 2 plus 1 over 2. Okay, and all the way down until you get the last term, 1 over 2. So 1 over 2 plus 1 over 2 plus 1 over 2 all the way down is n over 2. Okay, so this is the maximum number of Vn. Okay, I'm going to determine x1 through the x sub n. So in order to find this value, I'm going to give x1 equal to x2 equal to x3 all the way down until we get the last term, which is x1 equal to the xn, x sub n. So equal to pi over 4. Let's set x1 equal to x2 and all the way down to xn equal to pi over 4. Okay, we have our sequence. I'm going to bring this one to the sequence. So I have Vn equal to sine x sub n multiplied by cosine x sub 1 equal to, I'm going to plug a pi over 4 into this sequence. I will have sine of pi over 4 multiplied by cosine sine pi over 4 multiplied by cosine pi over 4. Okay, equal sine pi over 4 equal to square 2 over 2 multiplied by square 2 over 2 plus square 2 over 2 multiplied by square 2 over 2, and all the way down until we get the last term, square 2 over 2 multiplied by square 2 over 2. Okay, as you know here, so the Vn equal square 2 over 2 multiplied by square 2 over 2 equal 2 over 4, which is 1 over 2. 1 over 2 plus 1 over 2 plus 1 over 2, and all the way down until you get the last term, 1 over, which is n over 2. Okay, as you see here, I found the same value, which is n over 2. So Vn is taking n over 2 as a maximum number if x sub 1 equal to x sub 2 equal to x sub 3, and all the way down until you get the last term, last term except n equal to pi over 4. Okay, I have done with this problem. Thank you for watching. I will see you in next video. Bye.